In this video, we're going to be talking about extrapolating the third isometric view given two of the three isometric views of a part. This is something you'll have to do for various mechanical engineering courses. What that means is, given these two views, we have a top view and a front view. How do we know what the right view is? How do we define the right view? Well, we can think of it as an arrow pointing to the right here and an arrow pointing to the right there. That's sort of like where your eyes are and you're looking in that direction. That's what you really want to think about it as. And so when we look at this sort of stair shape from the right, well, we're going to see the outer bounds of the stairs as a rectangle. And we're actually going to notice that each of these features gets translated across. Every single line is represented in this part. You can see the top and bottom are represented by those top and bottom lines. And we can see that sort of each stair face, well, it's going to be represented by solid lines there in the middle. And so this is what our right view would look like. And we'll just sort of clear this up a little bit. This is what our right view would look like for this given stair shape. So now let's move on to a slightly more complicated version of that first drawing, and let's interpret the front and top views and try and figure out what that right view is going to be. Well, if you remember, each of these features is going to be represented in that right view. And so we can draw these sort of translation lines. We know that each of these lines are going to be represented as some feature in this view. So you can kind of see we're going to have some like lines here, right? We don't know exactly where they are, so we can't really place those yet. What we do know is that this back stair, it looks a little bit wider, a little deeper than those front two stairs. So we have our normal shape, but now we actually end up with those front two stairs looking the same as the last view, and you can see we're translating all of these lines over. But what we're going to do here, and this is the trick to this problem, is we can translate these lines over, but you can see they're not going to hit our part. They're in a different view. So we actually mirror those lines over a 45-degree angle. And so this line gets mirrored down to there. This is a trick for completing a third view, is you can take the diagonal view, right? For our right view, we can look at the top view, and those horizontal translation lines, they're not going to hit our part. The front view, they're going to hit the part, and that's going to be really easy. But for the top view, we have to use this sort of auxiliary diagonal mirror line, and that allows us to translate those features down into our right view, and so we can make sure we define those front two stairs as being a little bit smaller than that back stair. That back stair is a little wider, and you can see it's taller than those first two. And so we go back and just sort of tidy up our answer. Give it a little bit of space. So this is how we would draw the right view. So in this view, we're actually not given the front. We are given the right and the top. So how do we go ahead and fill in all of those features? You can see we've got 3 squares in the top view, 2 squares in the right view. We're kind of seeing a little of a mismatch. It's a little tricky. It's really not immediately obvious what the shape of this part is. And so the first thing we want to do is make sure that each of these lines is sort of translated down. We don't want to go too far with it. So let's just go a little bit down like that. And each of these lines is going to have to be represented in the part too. And so now we sort of see we've got these like instruction lines. How do we know where to place our object lines? Well, we know we're going to have a full width part in both views. We're going to touch the top and bottom and the left and right bounds of that full square, right? We've just drawn a rectangle here. Our shape is not a full rectangle, but we know that we're going to touch those left and right and top and bottom bounds just from seeing that there's an object line at the top and bottom and the left and right in the top view. We know we're going to be tracing those lines down somewhere. And so the trick to this is trying to visualize any kind of shape that you can think of that would satisfy these two views. And this really does rely on a strong sort of ability to imagine what a part is going to look like in 3D space, right? Because there is no like algebraic equation to solve this. You really have to understand what's going on here. We know that we have a line all the way down at the end and down at the beginning. And in order for these to all be object lines, we know that since this is an object line, it is a feature on the top because it is seen as an object line and not a hidden line. And so we can end up finishing out the shape like this. And so it's a little confusing, right? How did we get to this shape? It seems like we skipped a bunch of steps. Well, we did, and that's because a lot of these steps are just having an understanding of how a shape could fit this, right? You know you have to meet the top and the bottom and the left and the right bounds with some kind of a line. And we see that in this view, it almost represents like a feature sticking up, right? We see that object line sort of dictate a rectangle protruding up off the top in that top view. And so we know we're going to have sort of like a feature that sticks up in the front view. And we know that in our right view, we have to fill the full width, and we know that how tall it is from this line here. That line there tells us how tall this little bottom base feature is. And so from that information, we are able to conclude that the front view is just a simple sort of upside down T shape. All right, that's going to conclude our interpolation of two isometric views to find the third isometric view.